Every one of us wants to improve our mathematical skills. Whether you're undergraduate, whether you're a graduate, or whether you are pursuing further masters or advanced studies in mathematics, each one of us wants to improve our critical thinking. Each one of us wants to improve the way we are doing mathematics and thereby get a good score in our career assessment examination and get a fine and a well-built structure into mathematical understanding. In this particular video, I'm going to tell you what are the tips, tricks and techniques in improving your mathematical skills. Kindly note that this particular video is not meant that whether you're doing a master's or for graduate or undergraduate. It is a generic kind of a video which is going to improve your mathematical skills, which is going to give you certain do's and don'ts through which if you study mathematics in your classes and otherwise, you will be benefited. You will overcome the anxiety that you have in mathematics and thereby you will start falling in love with this particular subject. My name is Shaunak and you are watching this particular video on Physics for Students and I welcome you to my channel. The first thing that you must imagine that suppose that you are in a class, it can be a college class, it can be a school or whatever, and you have got your professor teaching. The class duration is for 25 or 30 minutes and during that time duration you might be able to understand certain things which your teacher is teaching and you might not be able to understand. Now what if those points or those equations which you do not understand? Will you again go back to the professor? Might be the teacher is busy, might be you don't have the time to go. So what can be done in order to get a complete understanding of what is going in the class? First tip right on your screen is what is called write everything in the classroom. Now there might be certain problems you might say that if I write everything in a classroom rather than if I listen to the teacher, is it going to create a better impact? I would say no. Now the thing is that within that span of 30 minutes you have to understand that the teacher also knows that the entire syllabus or the entire curriculum cannot be covered in that 30 minutes stipulated time. The teacher also knows that, possibly you also know. So there will be certain phases in the learning which will be fast, which will be much faster than you can imagine and you might miss on certain points. So what I would recommend is this one, write everything that is there in the classroom. So you've got a board, something the teacher is writing and you're writing every single thing. Now it might happen that you might understand certain equations, problems, calculations, etc. or you might not understand. I would say those things which you are unable to understand, that is absolutely fine. You can come back to your home, open the notebook and see what are the things that you really understand and what are the things that you really don't understand. So there is a time when now you can sit back and reflect, open your notebook, open your homework classes and open your books and then you start studying and developing those ideas that yes, these are the areas which I don't understand. So now let us compile with the book, let us compile with other notes and see that whether I can understand those things or not. Rather than sitting and just listening to the teacher in which you might think that this is not relevant, this is irrelevant, those things which you might thinking might come as an error. That means those things are important. So I would recommend take down everything that the teacher writes on the board, which he writes on the whiteboard, otherwise on the I would say the projector, etc. and take a note of every single thing. If you take a note of every single thing, you can come back and you can further study, you can reflect on those ideas and in that way you won't be able to miss anything. And also I can tell you that when you are listening and when you're writing something on the notebook, it creates a difference. Once you start writing things, it becomes much more clearer. So point number one, I would strongly request, or you can say I can advise, is that please do write everything that is there on the board or which is being discussed in the classroom. Second thing which I would strongly suggest is this one, start interacting in the classroom. Now, there are people, if you talk of my case, I have been very shy throughout my academic career, especially till my college and universities days. Whenever there is a question, raise your hand. Yes, sir, or yes, ma'am, can I answer this thing? Can I tell you? It might happen that you are making something wrong. Whatever your answer is, that answer might not be correct, but that is okay. I mean to say, we are all learning, so there is nothing which would say that, okay, whether I would feel embarrassed or etc. No, there is nothing called embarrassing. I would suggest that once you start interacting in the classroom, the biggest thing that is going to happen is that, first of all, is that you will learn at that particular moment. Immediately when the discussion is being held, whether it is Calc 1, Calc 2 or basic trigonometry or algebra, you will learn immediately what is being discussed at that point. Things get cleared up then and there. Second point is that, you know, the teachers, when I passed out from my college and when again I revisited my college or school, the students, the teachers remember, oh yes, Shaunak, you have been very shy. I know you used to sit quiet and do your sums. So once you raise up your hand, sir, can I answer? Sir, can I do that? That means the professor or the teacher remembers you. That means interaction helps you to grow. Interaction helps you to make a recognition in the classroom or on the class, right? So eventually you never know that you need that professor, right? You need the professor to maybe for a thesis paper, you need the professor to put up a signature, or there can be innumerable reasons. So if the professor remembers you, it will only happen once you interact in the classroom. Otherwise, if you keep shy and if you sit in the bench and just doing your own mathematics, etc., it really doesn't help. I mean to say, I have not done that and I would recommend you to do that. So please do interact in the classroom. Interaction helps you to grow. Interaction helps you to learn. And most importantly, interaction makes the professor or the teacher remember you, which is very, very important in the near future to come. The third point, which is right on your screen, is called read the book. Now, when you are going to a particular kind of an examination, or when you are going through your studies, most important is that most of us, we do not read the book. Either we consult internet, either we consult notes, either we look into the videos of mathematics. I'm not saying that these are wrong. These are absolutely fine. But reading the book, especially the textbook, is important. Why? Number one, you might miss up on something very important. Number two, books would help you to understand the entire syllabus. Number three, the entire nature of your examination. I mean to say, where from the sums will come, what would be the type of the sums. There might be a solution which is already given in the book which you're ignoring. So reading the book is very, very important. It enhances the overall understanding. So my request to all of you would be not to skip, but complete the entire book, which will help you make you understand. Coming up next, right on your screen, which is called forming groups and start studying. Now, I have discussed this earlier also. The basic importance of forming groups are many. Now, number one is that when you are doing mathematics, I'm talking especially for grad or maybe master students, when you're studying for more than say 8-9 hours a day constantly, sometimes you feel exhausted. Oh my goodness, I need to get a break, kind of a thing. But what if that break is also a break, vis-a-vis it is also a study, right? So first point number one is that when you go to a group, you would relax, and that is very important. You talk with mathematics, but you talk with friends, co-colleagues, people whom you really love and want to interact. So number one is that you relax a lot, which helps you in understanding. Number one. Point number two is that whenever you're going in a group or you're forming a group, remember, I'm not talking of a WhatsApp group, right? Physical groups where you go to college or somebody's home, where you interact, get around with people and you're physically interacting, not WhatsApp group. The second thing what happens is that when you're going through a group, I told you the first point is relax. Second thing is that suppose you have got a mathematical problem and you're approaching in this direction, right? And you see your friends approaching in this direction, you're approaching in this, which is totally different from this. You have an opportunity to learn more, because you might say, oh my goodness, I have never thought the mathematical problem to be such. I never thought that if the angles of a triangle can be given as thus, then we can solve this. That means what? You are exploring new ideas, you're exploring new thoughts, you're exploring new avenues of mathematical thinking. So the second point is very important, that there are many different ways of solving a problem. If you stay confined at your home, you would never be able to achieve this. So my strong suggestion would be create groups. So point number 2 would be to learn and look problems in a totally different perspective, which you don't know, which you don't perceive. Third point is that, this is very important, whenever you are interacting in a group, whenever you're talking in terms of group, obviously you're explaining those things, right? I mean to say, you're explaining, okay, come on, for example, your friend, I think that if you solve, suppose he or she has not been able to solve the problem and he has come to you and you already know the solution. So you are explaining the solution to that person. So once you explain those solutions, it becomes much more clearer. It becomes much more easier. Even you might think, oh, no, I thought that this part is not a little bit clear. You again go back to your study and you brush up your skills. You rethink on a particular problem, isn't it? So there is a famous saying, if I rightly remember, it is called, until you teach, you cannot preach. That means you're preaching a kind of a thought, an idea, which is not done until you teach. I will tell you a very honest opinion. The whole idea of launching my YouTube channel is to really know that how much I really understand myself. Be it general relativity, topology, differential geometry, calculus, philosophical thinking, whatever. Now, when I started my YouTube channel, honestly, I felt that no, some of the concepts are not yet clear. For example, tensors, for example, differential geometry. I have to go back, revisit, and then again I have to give a kind of a lecture on the video. So the best thing is that now that I have got huge amount of subscribers, even those who are watching this video right now, I'm really thankful to you that it is you who have helped it grow. Without your support, it has not been possible. So a lot of gratitude and thanks to all of you. Anyway, coming to this point, so until you teach, you cannot preach. It means that until you are teaching something, it won't be possible. That only happens in a group. Now come on, you cannot call your parents and tell, okay, I'm going to explain what is calculus, okay, I'm going to explain what are complex equations. So it happens only with groups of similar people. So very strong idea. Please start to form a group, not a WhatsApp group, a physical group. Number 1, you relax. Number 2 is that you take you get different perspectives of the same mathematical problem. And third, that once you start teaching, lot of concepts will become clear. This is pretty important. Go slow with your calculations. Now, there are people who are very fast. For example, I can do a lot of mathematics, lot of calculations, lot of complex equations very fast. I mean to say, when I teach my daughter, she used to say that, Papa, go slow, because I really don't understand the calculations which you're doing, right? But that is not done. I mean to say, that is negative. The reason is that when you are pretty fast in doing calculations, you miss out on critical and deep thinking. I again tell you, you miss out on critical and deep thinking. The reason behind is that when you are pretty moving fast with the calculations, then the problem is that you cannot go deep into that, understand, analyze, and possibly make out further solutions. Right, so you're going pretty fast, you have solved the problem, and then you can go to the second, third, fourth, and so on, and immediately finish a book. But that actually doesn't help you. I'm telling you through experience. It really doesn't help, because slow calculation and slow understanding really helps you to go and move further. Let me give you an example. Very recently, not recently, I would say around 3-4 months back, I was working on a video of Dr. Roger Penrose, the famous Nobel laureate who won the recent Nobel Prize of his black hole, works on black hole. Now he told that I was pretty slow in terms of calculation in my school days. Whenever teacher used to give me a problem, I used to look outside the window and used to think maybe I will take 4 or 5 minutes more time than the usual. I'm not saying this is a perfect example, but look at Dr. Roger Penrose. He is the famous Dr. Roger Penrose, working on singularity and black hole, and got the Nobel Prize working with the celebrated physicist Dr. Stephen Hawking. Now, I'm not saying that this is the ultimate experience, this is the ultimate reply, but if he has been a little bit slow in developing thoughts and ideas, look the way, the depth of analysis that he has done, the way he has approached a black hole problem from a geometrical point of view, not based on Einstein's field equation or exact solution. Anyway, that is a different issue. So the point would be, go slow with your calculations, the key word, because if you're doing it slowly, you eventually get time to reflect, time to understand, and time to think deeply. And that is very important in terms of going further with mathematical career. Redo your homework. Right on your screen what you see, this is an absolute necessity. Now, very recently, I think around about 15-20 days back, when my daughter is studying, she is pretty young, so they are also given a kind of a redo homework. I mean to say, you need to redo the homework. She was telling Young that I won't redo the homework. Same thing, do I have to repeat? Yes. You have to repeat the same thing. The reason is that, for example, a calculus or a differential geometry or any physics or mathematics problem, you are solving in a certain way, absolutely fine. Now you are redoing the homework and you are again attacking the problem, obviously without looking into the solutions. So what is happening, you will eventually see, if you are going slow and you are redoing the homework, then you get a chance to do that particular problem in a different way. So what is happening is that you are inventing a new method, you are inventing a new thinking, you are inventing a new way of attacking the problem. So that is why we say practice and practice. So this is important, that you are redoing the homework. That means you are again attacking the same problem, and I promise you, if you do that, you will find out a new way of doing or finding out the solution. Don't you think that is wonderful? Don't you think that is very creative and innovative? Doing the same problem creates a kind of an innovation and creates a kind of a way in which you can further redo the problem, further attack the problem, and further find out a new way for the solution. Now, this is something I really don't have to tell much. Do not touch your calculator. I know that for further studies, for example, those who are undergoing grad or master's degree in mathematics exclusively or physics, you have a kind of a problem and you really know how to solve that, but due to big mathematical calculations, you just take your calculator, I mean to say, you solve it and you get the answer. I won't say it is wrong. At some point of time when you're pursuing masters or otherwise, this is absolutely fine. But what I would also like to tell you is that if you do and remove the calculator and you have a habit of doing the calculations in your head or on pen and paper, I mean to say, that is also a new learning. You solve it in calculators, but if you solve it with your own head, with your hand, and doing the calculations manually, then that is also new learning. I mean to say, these are new learning process. Maybe you solve a calc problem, you find a exponential rule, and then you solve it. So what I'm saying is that if you remove the calculator at some point of time and you do everything manually, then that is also new learning, and that is also one of the integral part of improving mathematical skills. We all set targets for everything in our life, right? We have to get up early in the morning, do a little bit of jogging, then go back to our college, curriculum should be completed, come back to home, take time to your family. So what I would suggest is that set yourself a target and a time. That means 1 hour, maybe 45 minutes you're studying in mathematics. Please do that and do it regularly. And give a target. I will do 7 mathematical problems, or Calc 1 or Calc 2 problem, or a proof-driven problem in around 1 hour time, and that is okay. Don't go below that. I mean to say, if you're setting a target of 7 mathematical calculations in an hour for a grad student or a proof driven program. I know it might be okay or might be a little bit heavy for somebody else, but what I would say is that please do that. Set yourself a target, don't go beyond the target. Set up a kind of a clock or something right on your I would say on your table, and do that properly. What it will improve? Number one, it will increase your speed. Number one, it will increase your power of calculations, because you have to complete that calculation within an hour's time. Third is concentration, because for 1 hour you are focusing only on the mathematical problem, because you know if it is 1 hour 5 minutes or 1 hour 2 minutes, the time is gone. So you're improving the speed of calculation, you're improving the speed of doing mathematics, and most importantly, you're improving your concentration power, and thereby if you concentrate for 1 hour, you will see there are a lot of mathematics which is being done. So very important, set yourself a target, an achievable target, obviously an achievable target, and a time by which you can finish. Before we close down this video, I just wanted to quickly tell you that there is an obvious question of getting frustrated among people, is that this one which you see on the screen: why should I do mathematics? Most of the students, or I am not blaming the teacher, I myself being a teacher, do not have a proper objective of doing this mathematics, right? So why should I do the mathematics? Because I cannot see anything which is coming along the way of doing mathematics. Right on your screen, I wanted to show you 6 important points: the problem solving skills, innovation and creativity, logic and reasoning, developing transferable skills, learning to think, not memorize, and to understand, and the beauty of nature. The problem solving skills will become very, very important. I mean to say, not only in mathematics, let us forget about mathematics, right? And let us think about anything: geography, statistics, oh again I'm talking of mathematics, geography, history, maybe computer science, say for example. Whatever you are encountering, the problem solving ability to solve, even it can be finance, even it can be a crisis, for God's sake, that you're facing in your family. It improves the problem solving skills, and eventually you will see that you can solve problems better. Second thing would be innovation and creativity. It improves a lot of innovation. I just told you that when you're doing the same homework repeatedly, then you are innovating new ways, new avenues of doing the same thing. Logic and reasoning, obviously it improves. Developing transferable skills, for example, leadership, communication, I would say interaction, coordination. Why we call it transferable skill? Because these skills can be transferred to some other department. You can go as a PRO, you can go as a sales head, you can go as a chartered accountant, you can go as an engineer. Everywhere communication, leadership, coordination, these come into play. So transferable skills are getting improved, which will be overall applicable in a wider dimension. We will learn to think and not memorize. Yes, because once we start thinking and not memorizing, which happens typically for a proof-driven, a real analysis or something, that you really know the formula, then you have to derive the formula. Or general theorems, general Euclidean theorems, they also give you a way where you can think, rather than just mug up, memorize the formula and do well in the assessment. No. So mathematics gives you the power and the logical reasoning, and thereby to think, not to memorize. Lastly, I would say the beauty of nature. Oh, wonderful. I mean to say, I am right now in my study, so generally you have seen my videos up in the stairs. The beautiful grass, beautiful people around, the river, flowing down, the stars, etc. These are all beautiful in nature. These are beauties in nature. But we are unable to understand those beauty because we don't have the mathematical eye. And somebody really pointed out, I don't remember, possibly Carl Gauss, who told that the beauty of mathematics can only be seen by somebody who has got the eye of the mathematician. So the beauty of mathematics can only be enjoyed in case that you have a mathematical eye, right? So right on your screen, you see I have shown you certain knots. So these are tie knots which we tie: Windsor knot, half Windsor, 4-in hand, etc. Then I will show you something very interesting: shoelaces, right? You see double back, lattice, hidden knot, etc. So obviously I'm not trying to teach you how to tie the shoelaces, right? But what I'm saying that the beauty of the knot, which is the tie knot, is also a part of mathematics, which typically called, it is not related to tying of the knot, but it's called knot theory, right? Then the shoelaces, even these are beautiful structures. You see right in the screen, I am showing you the logo of Twitter, and research says that the Twitter logo is also made on golden ratio, and you all know what is a golden ratio, right? Now these are what I'm trying to tell you, these are beauty, these are wonderful structures which you can see through mathematics. Now also what I would like to show you, right on your screen you see a simple equation, a plus a equals to 2 times a. Now it's obvious, 2 plus 2, 4 equals to 2 into, right? So you get 3 plus 3 equals to 6 equals to 2 into. So on the left hand side we are finding something which is an addition, and the same addition we are looking in a different perspective, which is multiplication. And it is equated by an equal to sign. So the left hand side is the sum and the right hand side is the multiplication. And it is being equated by what we call is a metaphor equals to. So what I'm trying to tell you is that you see that mathematics is all of those beauty. You see it as a sum, I see it as a multiplication. I'm not saying that this is exactly the equation which I tried to mend, but what I'm trying to tell that this is exactly the way which opens up a different kind of a perspective in mathematics. If you do mathematics, you see the whole nature, the whole idea of life is changing in a different perspective. Lastly, before we close down this video, I would also like to show one favorite thing is this. Mathematics is a language. Most of us, I would say including me, we are not taught mathematics as a language. We are all taught mathematics as a symbol, as in language of symbols, is a language of utmost difficulties, which will contain a lot of problems, concentration, and no, you are not meant for that. You are not the person who is made for mathematics, right? But what if I show you something very unique? Look into your screen. What I try to show is that if you ask a kindergarten student or a child what is 1 apple plus 1 apple, they would eventually tell 2 apples, right? So here addition is not important. What is important is the language. It is 2 apples. Now if similarly I can show you 1 pencil plus 1 pencil equals to 2 pencils, right? So right now what we are doing is that we are approaching mathematics as a language. Now if you ask the same kindergarten guy or a child what is 1/3 plus 2/3, now ignore the part which you are watching on the screen, that fraction. I want you to ignore that and see what is 1/3 plus 1/3. It is 2/3. That means you see, if I keep the apples part and the pencils part vis-a-vis, 1 apple plus 1 apple equal to 2 apples in a language, and 1 pencil plus 1 pencil equals to 2 pencils in the language form, then 1/3 plus 1/3 equals to 2/3. That child doesn't have to know fraction. What if 7x squared plus 2x squared equals to 9x squared? Even without learning exponential, just following the algorithm of apple plus apple equals to apples, pencil plus pencil equals to pencils, 7x squared plus 2x squared will be 9x squared. And you see most of the time which I want to show you is that this particular, what you see on the screen, 7 multiplied by 3 is 7 times 3. We are not taught on that. We are taught 7 3s are 21, 7 4s are 28, and so on. So 7 multiplied by 3 equals to 21. That means 7 times 3 or 3 times 7. That means we are writing 3 plus 3 plus 3 plus 3 plus 3 7 times. So this is what I wanted to show you. Most of us are taught mathematics as an equation. Most of us taught mathematics as something difficult. But most of the students, you will see, kindergarten, they are not taught that 7, this multiplication sign means 7 times 3 or 3 times 7, which is 3 written by 7 plus 7 plus 3 written 7 times. So just before I conclude and end this video, I just wanted to give you a message to all of you, is that let us try to understand mathematics as a language. not as a mathematics, a language of symbols. Yes, symbols are there, but it is more of a language. If you are a teacher and you're watching this video, my earnest request to you would be to teach mathematics as a language, and I always try to do that. Things will become easier, things will become faster. Okay, so we are done with this video. Just to sum up quickly, let me just give you a wrap up through the points which we have done. First is that you need to write everything which is mentioned in the classroom. Start interacting, raise up your hand. Hello sir, hello ma'am, I know the answer. Read the book thoroughly. Form small groups so that you can interact, and remember that saying, until you teach, you cannot preach. Go slow with your calculation. Don't rush with your calculations. I mean to say, we know that you may be very good in terms of calculations. Go slow. Assume the calculation right. X equals to 1, given x equals to so, and then solve the problem. It will eventually make things faster and will open up avenues to study. Redo your homework, because again it will give new innovations. Please do not touch your calculator until you reach at least a master's degree, because doing those calculations again and again will improve the thought, will improve the calculation process. Set yourself a target and a time. Set a time through which you can really do things that will make faster calculation, that will give you a target, and that will most importantly improve your focus. I have already explained why should I do mathematics. You should do mathematics because it will improve the critical thinking and problem solving abilities. Lastly, please treat mathematics as a language, not something which is difficult. That's all I wanted to share you. These are the things which you can rigorously do. You can improve your mathematical skills and also get a good score in your assessment and your further examinations. Please don't forget to like, subscribe and click on the bell icon to get all the notification from Physics for Students. This is Shaunak signing off right now, and I will wait for your comments, and if you have further suggestions in which you can improve your mathematical skills, I will be happy to get a note, and I will put up those comments when I make another video on mathematics for sure. Till then, goodbye and wish you all the best, and wishing you a great day ahead, and I'm sure that you're going to do great in your future endeavor, building up a bright and a prospective career in mathematics. Thank you very much for watching this video.
Now, you can be a part of our team. You can send your scientific articles, essays, research papers, lesson plans on a particular subject of science. For further details, please write to us at editor@physicsforstudents.com. Stay safe and happy.